నమస్కారం. డాక్టర్ బిఆర్ అంబేద్కర్ సార్వత్రిక విశ్వవిద్యాలయ విద్యార్థులకు స్వాగతం. ఈ ప్రసారంలో
Hello students, we are going to have a lesson on holography. This unit is there in your optics semester 4. We know the meaning of holography. In Greek, holos means complete, graphos means writing, holography means complete writing. Here complete writing means getting an image with amplitude as well as phase, which gives a 3D image as good as the object. We see this slide. In this, the person who incorporated these ideas is Gabor of England. He did this work in 1947. This method of recording and reproducing was discovered by him while he was improving resolution of electron microscope. He was awarded Nobel Prize in 1971. In this you will have an object, it is written as subject here, the photosensitive medium on the right side, and we have a source of light and a mirror. This light from source falls on the so called subject as well as onto the mirror. From the mirror it gets reflected and it is reference beam. Whatever light that comes from the subject is called subject beam. These two beams are supposed to interfere. When I say interfere, we require a source that is something like a coherent source. Before laser was invented, the coherent sources were sodium light and the associated ones. They were very difficult to handle, and Gabor did this work during those days. Now when we say interference, we require to explain the wave property of electromagnetic light. See, light wave is an electromagnetic radiation and it contains electric wave as well as magnetic wave. Our eye and many other recording instruments like cameras and other things are insensitive to magnetic wave, hence we have to depend on the electric wave variation. So this electric wave variation is now written in the form of an equation as Et is equal to, now see the slide, Et is equal to E0 sin omega t plus phi. Et is the instantaneous value of the amplitude of the electric wave, E0 is the maximum amplitude and maximum value which is called amplitude. Sin omega t plus phi gives phase or location of the point on the wave. This I have made it to show on a simple moving diagram. Now what we observe in a particular photograph is the intensity of it. We do not have any information about the phase of it. So for that purpose, the amplitude of the wave square is proportional to the intensity. So we cannot see light wave at all. We cannot see any wave pertaining to electromagnetic radiation. We will only experience or perceive the indirect effects of it, that is the intensity. This intensity which is there on the photograph of a general photograph, a 3D object is being taken as a photograph on a 2-dimensional paper, hence we see only intensity. For example, I would like to take the example of this particular flower vase. We have several depths of this flower vase. This flower is pink and it has a different focal plane. We require to focusing of a particular photograph to get it on a 2-dimensional paper for the 3-dimensional object. This particular thing I take an example of these flowers of different focal planes. This is one flower, call it as red, and this red flower is at one focal plane. Now, we have to change the focal plane as the camera is to be continuously focused on to, for example, this green leaf. Then it has to be changed to another focal plane, that is on this violet. That means, what is happening? We have several focal planes in this, all of them cannot be focused at a time. This is what is happening in a particular photograph. Hence, we project it onto a 2-dimensional one. Now, what we need is focusing, that is the real problem in 2-dimensional photograph. Projected 3-dimensional object photograph is projected on 2-dimensional paper. Focusing is the real problem, and the next one is information about phase is totally not available. We talk about amplitude and not phase. This was the situation before Gabor found out that new thing called holography. Now, in holography, at each point of the plate, that in the photograph plate, we observe the interference occurs between two things. These two are A, undisturbed amplitude, B, the transmission diffraction field of the same object. So, this undisturbed amplitude will be there at every point on the object, and transmission, once light is transmitted, diffraction field will be automatically available. Now, here in general we find A is very much greater than B. So, this we observe in this slide. Now, as far as this to occur, we need a coherent light source. The earlier days, the coherent light sources were somewhat nearly coherent, not totally coherent, but even then they produced very good interference. This red color, pink color line that we are observing in this wave is intensity distribution because of double slit, because of interference, double slit interference. The same thing we will observe double slit interference pattern, and we will have diffraction pattern also, double slit diffraction pattern also. You can observe diffraction pattern. This is a contour that is coming down, so that the inside the maxima minima are being modulated by the diffraction pattern. So, this inside lines maxima minima or interference maxima minima, and outer contour is diffraction maxima minima. So, both will occur in holography. In our next slide, we will observe that what Gabor did is a slit. Through the slit, the coherent light source falls on a lens, and it comes to a focus f, and it turns to onto a photographic plate and falls on this. This particular one is the point of focus. Off the focus, out of the focus, slightly away, we will have the object. This object is very nearer to it, and at such situations Gabor found that the coherence will be very good. So, this object is pictured, that is recorded, and then we observe the recorded one is being available here. So, that means we have a hologram recorded. Now, the light that is falling from the slit onto the lens again onto the hologram. Now, this is falling on the hologram, the light falls on the hologram, and instead of the object we remove the object there, we will keep the hologram, we will get the information on the hologram. The advantage is, in the hologram we have different focal planes that are available for the object. Now, condition is the object must be a transparent one and it must be in such a way that we will have a small size because of the conditions that are imposed on this. Now, this object will have its holograph on this and it will have a pseudo image on this side of it. When hologram is on this side, pseudo image will be on this side. As soon as in 1960 laser was invented, and using laser, two scientists Leith and Uptonix, both these people, they have done several experiments and they produced a better recording on hologram, and this is the first laser recording was done in the hologram. This is a small train like thing and a bird like thing that is there on the train, and you observe this is the first laser recording done by scientists Leith as well as Uptonix in 1964. What they have done I am showing in this diagram. Look into this particular slide. This slide is recording a hologram, coherent beam of light. Coherent beam means all the waves that are traveling are understanding with each other. That means crest is on crest and trough is on trough, that is the sort of understanding. Now, that such coherent light beam falls on a what is called beam splitter. A light beam falls on this, it will split, part of it is reflected down, part of it is transmitted through. So, the reflected one will fall on a mirror arranged in the suitable angle and it gets reflected and falls on the photographic plate as a reference beam, and the splitting at the splitting the transmitting beam will be falling on the so that it is illuminating the object. So, you call it as illumination beam and it falls on the object, and from the object it falls on the photographic plate. We call it as object beam or object wave. So, a reference wave, object wave, two things must fall on a photographic plate. This is how it is being recorded. Now, once it is recorded, we keep the photographic plate which is the hologram, and we see that the reconstruction is being done by using a beam, and virtual image is observed at this particular place as the light is falling on this and coming down for the reconstruction of the waveforms. You see the viewer is at the down and the virtual image is now available at this top. So, that is how recording and reconstructing. Now, the photographic plate is darkened more at places where the two amplitudes are in phase. We see that interference is occurring. In this interference, we will have interference of two types. One type is in phase, another type is out of phase by 180 degrees. So, a darkened place is a place where in phase, that is phase difference to be 0 or 360, two amplitudes are totally cohering, and this lower one is out of phase by 180 degrees, and this produces a lesser darkened place. More darkened is in the 0 phase difference and less darkened is the amplitudes are out of phase by 180 degrees. This we can understand by using this particular hologram that is being taken, that particular picture. Now, on developing the plate, we get a representation of the amplitude of the diffracted wave on a uniform background. Here, when we say the amplitude of a wave, we have seen the diagram of a wave. We will have positive amplitude going up in the y direction and negative amplitude going in the downward direction of the y. Positive amplitude is being represented by dark region and the negative represents the less dark region. The left side figure is the image or the hologram. You find this less dark and more dark observed in this. And the undiffracted wave is used as a carrier wave. Now, in radio transmission and various transmissions, we will have the carrier wave and the signal wave. In the same way, here we will have a carrier signal and the modulating signal. The carrier signal is this interfering signal, and the modulating signal is a diffracting signal. Ultimately, these two put together, there must be a modulated one. This modulation is called carrier modulation. This carrier modulation has got the phase of this diffracted wave is partially recorded. Hence, this particular wave that you are observing, from smaller amplitude to amplitude increasing and maximum and amplitude decreasing, again it is increasing and it is decreasing, this is called the modulated signal. So, like this we will have phase is being recorded. To reconstruct the image, we remove the object and place the hologram and look for the reconstructed what is called a 3D image. The left side diagram is a hologram, and now with if you have a microscope focused at different planes, like what we have done in the camera, now focusing at different planes on this. If we have a microscope, we can use the different planes at different parts of the holographic image, and we will see the entire 3D part of the object. This is what has been done by Gabor while he was trying to improve the resolution of the images taken from the electron microscope. Next slide will give us the second image of the object located behind the focus. I have told you already the pseudoscopic and one. The original image is called orthoscopic and the second image is called pseudoscopic. Here I have shown you in this diagram, the right one is pseudoscopic, left one is orthoscopic. For the convenience, it is taken as a pepper as well as a salt, and it is reversed here, salt comes first and pepper comes late in that particular shadow. Now, as lasers have improved, there are associated equipments, a large number of associated equipment were improved, and they are called lens stops, and they are also called beam splitters, and various paraphernalia are improved. These things helped us to make the holography at a desired extent. The hologram that is produced by Gabor was very inferior compared to the latest holograms, but he has introduced the concept that is a very important one at the desired extent of the recording as well as reconstruction. The phase of the wave, that is very important. Now, in this diagram we will see the object is a cycle and light comes and falls on the partially transparent mirror and that falls on the object. This is object wave or object beam. At the split beam directly falls on this, and these two interfere and produce on the photographic plate a hologram. So, this hologram we will observe like this, that is recorded. Now, we will have other types of holograms, they are called transmission holograms as well as reflection holograms. The transmission hologram, reference and object wave traverse the film from the same side, that is transmission hologram. Now, in the reflection hologram, reference wave as well as object wave both traverse the emulsion from opposite directions. So, this is reflection hologram. We will see one example of this hologram. Children are around that and the teacher is showing them a hologram of this type of an animal. This is very interesting, and 3D movie holograms were made to show part of the films, like the earliest one is Star Wars. This happened before 1980 itself, and this is a film in which the person uses his gun to kill, and it is being shown as a hologram, 3D hologram with movie. Such things were shown in the movies also, and we have another, the so called future technology. We will have the projections, pop-up projections from the mobiles as well as from the laptops. The projections will come, the projections will be convenient for operations, and this is shown on the left side of the one as one of the examples, right side of the one is another example. Here ultimately it produces a virtual reality, and nowadays there are more improvements on the virtual reality, that is they are called augmented realities, and these are the applications. We will have plenty of applications of the holograms. The commercial applications are they put their sticker hologram onto the object so that it is not duplicated by any other company, and we will have various government agencies giving some sort of identity cards, holograms. When they are fixed onto them, they will be useful to identify. Like that, we will have plenty of applications of the hologram. All along we have seen the holography and its decencies, uses, applications. The basic principles of holography are the interference and diffraction of the wave nature of light. This was originated by Huygens wave theory, whereas until then reflection, refraction, total internal reflection, these were used to explain the properties of light using Newton's corpuscular theory of light, whereas Huygens wave theory helped scientists to explain interference and diffraction and polarization parts of the properties of light, and this helped us to invent holography, and holographic applications are plenty are there, and these applications are, we will have holographic interferometry. There is a field of science in physics like optics, interferometry. This interferometry is used to make measurements very accurate, and such very highly accurate and very nearby objects, they produce interference bands, and these interference bands, when you observe slight changes in the interference band width, we will, in terms of the band width, we will make the measurements. Like that, we have these things applied to even galaxies from where we are getting gravitational wave. These days you must have seen NASA has produced some measurement of their distances and gravitational wave and the associated one, that is possible only with the help of the interferometry.
మా కార్యక్రమాలపై మీ సూచనలు సలహాలు మాకు తెలియజేయండి. మీ సూచనలు సలహాలు మాకు తెలియజేయవలసిన చిరునామా: డైరెక్టర్, ఆడియో విజువల్ ప్రొడక్షన్ అండ్ రీసెర్చ్ సెంటర్, ప్రొఫెసర్ జి రామరెడ్డి మార్గ్, రోడ్ నంబర్ 46, జూబ్లీ హిల్స్, హైదరాబాద్ 500033.